Hi everyone, my name is Anna Thomas. I'm faculty from the Department of Renewable Energy. So in today's class, we'll be discussing the topic, the energy performance assessment in boilers. So first we'll see what a boiler is, its basic function, what it is used for, its application structure, etc. And then we'll move on to why or how the performance is assessed in based on energy. Okay, so let's start. So this is the basic diagram of a boiler. So from the word boiler itself, we know it is a word which is very commonly used in manufacturing plants, industries, etc. Why is it used? Boiler means to boil something, to generate steam or even boiled water. You give some input to a boiler, it will boil that content and generate steam or the boiled form of what we give. So this is the basic structure. In this structure, we have a basic component which is called the furnace. This is where the boiling action is done. So in order to boil something, what should we give? We need to burn it. So for the burning action, we have to give the fuel, and that in the presence of air undergoes combustion. And if suppose we are burning or we are boiling water, that water is also fed into the furnace. So that is called the feed water. The water we give for the boiling action is called the boiler feed water. That is given through this inlet. Then we have air and the fuel inlet. Air and fuel is given together for combustion to burn this or to boil the water. Okay, so that is furnace, one of the main components of the boiler. The next component is the boiler proper. Boiler proper is nothing but the device or a vessel which is used to from where the steam is generated. We know when water boils, when it reaches 100 degrees Celsius, it changes into steam or it starts evaporating. So that steam is collected here, or the condensate or the water vapor is collected in the proper, and that is taken through this pipe and taken for different applications. So here one application is shown which is just given to a turbine. Turbine will rotate depending upon the speed or the force with which the steam comes. This rotation of the steam or the turbine will lead to generation of electricity. So that is one of the applications. It has been used in many applications like textile industries, paper industries, thermal power plants, distilleries, etc. So basic components are just clear now. We have a furnace for starting the boiling action. For that we need to give the air and fuel as the for combustion. Then feed water, whatever we give for boiling. It could, most of the cases it is water, and we use it to generate steam. This steam is used for different applications. It could be used to generate electricity through a rotating turbine. So these are the basic things of a structure. So let's just summarize what I said about the structure. It is a closed vessel in which boiling action or generating steam is done. The heated or vaporized steam is taken out for different applications. Some of the applications are mentioned here: chemical industries, refineries, distilleries, thermal power plants, food processing industries, etc. Okay. Now, this boiler, as time goes by, as years pass by, their performance start degrading. What happens is sediments or the water, the quality of feed water, the water we give into the boiler's quality might change. The quality of the fuel we give might change. The sediments may occur. Some depositions or accumulations may happen in the boiler. All these will affect the performance. So that are the factors given here. One is poor combustion. Poor combustion means fuel in the presence of air undergoes burning. The combustion process might not be exact. There could be some dissimilarities or disactivities there. The next one is the heat transfer fouling. Fouling means nothing but the accumulation of unwanted substances. The deposits or accumulations might occur in the furnace. That will also affect the performance of a boiler. The third one is the poor quality of fuel and the water. The feed water we give for boiling, if its quality is not exact or if it is not up to the standard, what happens is it will affect its performance, and gradually the burner or the boiler will degrade. The last one is the poor maintenance. If you are not properly maintaining it annually or quarterly, it will start degrading. So all these are the factors which will affect the performance. So these factors need to be kept in mind. So what we basically do is we do a performance test to find out its performance. How is it up to the mark or is it up to the rated efficiency, etc. So the performance test is basically used to find out two components. One is two parameters. One is the efficiency. We need to find out the efficiency of a boiler. Next one is the evaporation ratio. Okay, so these are the two basic parameters which will decide whether a boiler is up to the standard or whether it is up to the mark. Okay. So purpose of the test is just summarized. One is to find out whether the efficiency is good, the evaporation ratio is good. Next is to find out if it is up to the standard, if it has met its actual rated. We know every device when we purchase, it has a rated efficiency or it has rated set of standards. So what we need to know is as time goes by, as we pass on, as time goes by, whether its quality is degrading or is it making it up, is it performing up to its rated efficiency. That needs to be known. So that is the purpose of the test. So let's see how we find out. As I said, there are two important parameters which will determine the performance of boiler. One is the boiler efficiency. Efficiency term, it is represented by eta. We know eta, efficiency is always, efficiency of any system is its output divided by input. So in terms of percentage, we divide it, multiply it into 100. So output by input into 100 is the efficiency of any system. So when we come into boiler, we know what is the output of a boiler. Boiler generates steam, or it could even be boiled water. So the steam is the output. So we need to measure its quality, or the quality of the steam. How can we measure it? We measure the heat in it. So we say heat in the output is the output of the parameter. Next one is the heat input. What is the input in a boiler? Input is we are giving fuel to boil the water. So fuel is the input. Fuel in presence of air we give. It undergoes combustion. It will burn and boil the water. So input side we have fuel, output side steam is generated. So output by input efficiency, we can say heat in the steam output is the heat output and heat in the fuel is the heat input. Both these parameters are taken in kilocalories that we multiply by 100 to get boiler efficiency. So hope that is clear. So always remember, efficiency of any system is its output by input. So when we come to boiler, what happens is in a boiler, the output is always steam. It needn't necessarily be steam. It could even be boiled water or a boiled form of anything we give into the boiler. Okay. So that quantity of heat it is there. The amount of heat in the output is the heat output, and the input side we are giving the fuel to burn for the burning purpose. So that is the input side. So heat in the steam output divided by heat in the fuel input into 100 will give you the efficiency. Next parameter is the evaporation ratio. So the boiler, we know that just as it is generating steam, right? So for what amount of fuel we give a fuel. So for what amount of fuel is the steam generated? That is the evaporation ratio. So in terms of equation, we can say evaporation ratio is the quantity of steam generated upon what quantity of fuel consumed. How much we give some fuel, from that fuel, how much of steam has been generated will give you an idea of the evaporation ratio. So from these two parameters, we should be able to understand how the performance, whether the boiler is performing as per the standards. Okay. So just keep in mind these two equations. Efficiency is heat output by heat input. Evaporation ratio is the amount of steam generated by amount of fuel that has been consumed. Okay. So now there are two methods basically to find out, to calculate these two parameters. Evaporation ratio has to be computed. Boiler efficiency also has to be computed. So there are two testing methods. One is the direct method and the other one is indirect method. We'll go into detail as to what each of these method means. Okay. First we'll take into the direct method. Direct method, just as the name suggests, it's a very simple method. We are not considering the losses or any other external parameters. Just output divided by input should give you the value. Direct method is also called the input-output method. Here we know when we give something into a system, that is the input, then there is a system, then output comes. But here we are not considering the losses. Whole of the input doesn't come into the output. Naturally, some things get dissipated, something gets stored, right? So that losses are not considered in a direct method. We are only considering the input and output. That is why it is called the input-output method. Here, just as we saw in the other equation, the basic equation of boiler efficiency, heat output by heat input into 100, we directly substitute the values there. Okay, so it is one point is it is an input-output method. Here we are only considering the steam and the fuel. We are not considering the internal parameters or the losses that occur in a boiler. So we'll just see how that is done. The calculation is done. This is just a schematic as to or the block diagram of a boiler method, direct testing method. So here this is just a block of a boiler. What are the inputs? We have a feed water for boiling. Then to boil this, we need to give the heat has to be supplied. That heat is given through the fuel and the air. So that is the input side. Input we have feed water and also fuel in the presence of air. Output, what happens? Steam is generated. This steam is taken for different applications. So one thing we have to note here is it is not just steam that comes out. There are also something called flue gases. That is the waste or the smoke gas that accumulates here or that has been produced from this process. Whole of this water doesn't get transformed into steam. Some combustion, incomplete combustion will lead to flue gases, or this is basically smoke or waste gas. So that outlet is also provided. Okay, so this is the basic diagram of a boiler's functioning. So we are going to calculate the efficiency of a boiler. So we know the equation efficiency is, as I said, it is heat output divided by heat input. Now how do we compute the heat output? What is the output? Output is steam. Steam is generated from the outlet and it is taken for different applications. So how do you compute the heat in the steam? That can be found out by calculating the rate at which steam flows. For that, we need a steam flow meter. So steam flow rate has to be computed. The unit is kilogram per hour. That has to be multiplied with the energy. How much of energy is there in the steam that has come out? That is steam enthalpy minus feed water enthalpy. Enthalpy means nothing, it's nothing but the energy per kilogram. So we have giving some water, that is the feed water. Steam is generated here. So the difference between these two enthalpies multiplied by the rate at which steam comes out should give you the steam output. Hope that is clear. That is the numerator of the equation. This equation's heat output means steam is our output. So it comes out at a particular rate. That has to be measured using a flow meter. Steam flow meter is there. It will measure the quantity of steam that comes out per hour. That should be multiplied with the difference of both enthalpies. Steam enthalpy minus the input, which is the feed water enthalpy. Now what we have is the denominator, which is the heat input. What is the input? As I said, input is the fuel in presence of air. So this fuel is also fed at a particular rate. That also has a particular flow meter reading. So that has to be, the firing rate has to be measured. That is found using another meter for measuring the fuel inlet. That is called fuel firing rate. Just as in the numerator we found out the rate at which steam comes out, we should also determine the rate at which the fuel is fed. That is called fuel firing rate, again measured in kilograms per hour, into the gross calorific value, the GCV value. Every fuel has a particular GCV value. That can be tested in chemical laboratories and found out. We don't need any special apparatus outside. It is just every fuel. Fuels could be solid fuel, liquid fuel, or gaseous fuel. Every fuel has a particular calorific value called the GCV value. That just has to be multiplied with the rate at which we feed in the fuel. So we'll get the heat input. So by dividing these two parameters, we should get the boiler efficiency. That is how we find out the efficiency by direct method. So that is what are the measurements to be taken is just summarized here. One thing is we have to find out the flow rate and the calorific value of the fuel. That is the input side. Input side, we need the flow rate or the feeding rate at which fuel is given. That is multiplied with the calorific value. And the output side also, what do we need? We need to find out the steam flow rate as well as the difference between enthalpies. So fuels are basically, as I said, of three types. Solid fuels are there. Liquid fuels. Liquid fuels example is liquid petroleum, etc. Solid is coal, or gaseous fuels like natural gas. So each of these fuels has their own calorific values. That is already predetermined in chemical laboratories. That is multiplied with the flow rate to get the heat input. So hope that is clear. Such different fuels have different meters. Gaseous meters will have gas meters. Then there are liquid meters as well as solid meters. We give it in a bulky apparatus. That apparatus is kept above the boiler and we feed in the coal if it is a solid fuel. That will depend upon the applications. We can use any of these three fuels for the boiling action. Okay, so that much of it is the basic concepts of direct method. For output measurement, as I said, we need an installed steam meter. That is to find out the rate at which steam comes out of the boiler. Then what do we need? We also need to find out the difference in enthalpy. Steam enthalpy minus feed water enthalpy. That when multiplied will give you the heat output. So now if we see this method, we can just notice that there are some merits as well as demerits for this method. The most important advantage we come across is in direct method, the calculations are quite simple. We don't need like many apparatus for measurements. What we just need is a flow meter to note down the readings, as well as you need to know the calorific values or the enthalpy values. If that much is there, you can easily find out the efficiency and the evaporation ratio. There are no much complicated calculations here. It is at just a glance, it is easy. So that is the main advantage. Any person can quickly do it. You don't need much of computation. You don't need much of instruments. Many instruments are also not needed. But there are many demerits. One of the common demerit is when we calculate, if we come across a very low efficiency value, we won't know why is efficiency coming down, or why is it not maintaining properly. We cannot know the exact reason why this boiler is not performing up to the mark. So that is one important disadvantage of this method. A decrease or a dip in the efficiency or evaporation ratio will not indicate anything. It will not indicate why it is coming down. We cannot know where the losses are occurring. So such problems occur in a direct method. That is given. It does not give clues as to why the efficiency is lower. Also, it does not consider the losses. There are many losses that occur inside a boiler. So that losses are not taken into account. Also, evaporation ratio and efficiency may mislead if the steam is highly wet due to water everywhere. So water carryover will happen, and then this due to the climatic conditions, when the ambient conditions change, evaporation ratio and efficiency values will have changes, because according to the atmospheric conditions, the steam generated may escape. That will depend upon the ambient conditions. So the readings are not accurate or exact because we are not considering the losses. So this much is the direct method testing. So which is, we are only considering the output and input. We divide output by input into 100 to get the efficiency. We do not consider the internal parameters of a boiler. So this is the first method. Now we are moving on to the next method. It is called the indirect method. In indirect method, what we do is we consider all the losses that occur in a boiler. We know, if I'll just show a schematic of how indirect method is done. In the earlier figure, we just had a boiler, steam output, flow gases just escaped. We never calculated any of the parameters of flow gases. We just calculated the steam, flow rate, and then enthalpy. Here input was given, here water is also fed in. But in indirect method, the flue gas or the smoke or the waste gas that comes out has a lot of losses. That is actually loss. Okay, we are giving the input and all of this water is not getting converted into steam. Most of it gets, no, a part of it is lost due to the moisture in air, the water vapor content, moisture in fuel. There is the fuel we give might have moisture content that may not undergo complete combustion, that will escape. Then the moisture content will be there in the air we feed in, that will escape. Then there are many emissions like carbon monoxide emissions will occur, dry flue gas losses will be there, hydrogen losses. All of the fuel doesn't burn or doesn't completely combust. So such process will result in ashes. Ashes, we know, they're the charcoal pieces, or the whatever fuel we give, that will turn into ashes. Some fly ashes will get lost. Some will settle down at the bottom of the boiler. So such losses are marked here as from 1 to 8. 1, 2, 3. 1 is the dry flue gas loss. Second is the hydrogen loss. Third is the moisture content in the fuel. Moisture content in the fuel doesn't burn the water or doesn't boil the water. It just escapes out. So such things are found in the atmosphere. So such values, all these values have to be taken into account when you actually determine the efficiency of a boiler. Such parameters should always be considered. That is what the indirect method stresses on. Okay, so that is just given here as an introduction. Here we consider the losses. Losses are the very important parameter when you find the efficiency and evaporation ratio of a boiler. Okay, efficiency is, so what we do is, we know for any system, when we say that it is 100% efficient, its efficiency is 100, right? So actually there are no such cases. 100% efficiency is practically not possible. There are many losses that occur there. So what we do is, we calculate all the losses in the system and we subtract those losses from 100. That is the second point given here. It is calculated by subtracting all the heat losses from 1 to 8. There are a set of 8 losses. So each of the losses we compute using separate instruments. We add up all the losses and we subtract it from 100 to get the efficiency. So that is the next method, or the second method of assessing the performance of a boiler. Okay, so here the advantages, we can know exactly each of the errors can be minute errors also. Least errors in the measurement will not affect our overall answer. We know because there are certain losses, we are computing each of the losses and corrections can be made for each of the problems. In the direct method, it was not like that. We just had an idea of the figures only. We never knew where the problem occurred or what was the reason for a dip in efficiency or evaporation ratio. Okay, various heat losses are represented pictorially as I shown. These are the different losses. Surface losses are all of some heat will be lost due to convection and radiation to the atmosphere. That is the surface loss. Bottom loss means the deposits may occur at the bottom and it will gradually degrade or corrode the boiler furnace. So such losses should be considered. Then we have different losses like due to the moisture content, etc. as I said. So efficiency, as we know, is 100 minus sum of all these losses. That is done in the indirect method. So in today's class, we just had a basic idea of what a boiler is, how it works, the basic principle of a boiler's functioning, and then we came across two methods. We didn't go into detail. We just introduced two methods in which we can assess the performance. One is the direct method, by which we just compute output by input, find out the efficiency. We do not consider any of the losses. Next one is the indirect method, in which we consider each of the losses. So for measuring each of these losses, we need, what do we need? We need different parameters or instruments to measure. So L1, I just named all the losses. What is L1 is due to dry flue gas, then due to the hydrogen content, moisture and fuel and air, carbon monoxide emissions will be there. So for measuring each of these, we have separate parameters. We are not going into much details of all that. To measure each of these parameters, specified instruments are there. Those instruments will measure these. That all we add together and we subtract it from 100 to get the efficiency by indirect method. So hope you got an idea of these two methods. We'll go into details of each of these in the next class. Thank you.